All right, hello. In this lesson, we will be covering 8.3 day 2. Our goal is to be able to graph rational expressions. So rational expression, if you forget what that means, is just one expression over another expression. And to do this, we're going to do vertical and horizontal asymptotes. Yesterday, we covered how to do the vertical asymptotes along with the holes. And this section will go over the horizontal asymptote and try and put it all together. All right, so there's a lot of steps. But here they are, right? These might be a good thing to have down in your notes here. Is our steps for graphing the rational function is factor it, the numerator and denominator if needed. Sometimes they're already factored. Then find vertical asymptotes and holes, and that's what we did yesterday, right? And in those we just set the denominator to be 0 and figured out those breakpoints, like what would create a divide by 0 situation. So that's how you find vertical asymptotes or holes. Horizontal asymptote, you'll have a chart later for your notes here that'll show you how to do that. And then once you have those, you plot the asymptotes and use your calculator to help fill in the rest of the graph. In this first video, I'm just going to review, right? So this is kind of just a review from yesterday of how to do vertical asymptotes and holes. All right. So here's a quick set of 3 questions. Pause the videos and see if you can figure out what are the discontinuities and if they are a hole or an asymptote. All right, hopefully you got a chance to look at this. Don't worry about this non-removable discontinuities. I changed that. So when you see this again, just focus on, is it a hole or a vertical asymptote? So for our first one, we want to say, okay, when is this denominator 0? And if you minus 7 from both sides, we find that that happens when x is negative 7. All right, then we would have negative 12 divided by 0, and that would be an error. All right, so to determine on our graph at negative 7, right, later today when we graph, we're going to be over here at negative 7. And so to figure out what happens is you have to say, well, does this little factor have a match up top? In this case, it does not have a match, right? So if there is no match at all, then this one is going to be a vertical asymptote. Okay, so this first one, vertical asymptote here at negative 7. So it looks something like dot, 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 something like that. Okay, second one, it's already factored, which is kind of nice. So we just set the bottom to 0 and say there's 2 points where the denominator would equal 0 when x is 1 and x is negative 3. Okay, and again, to determine are these two, is one of them a hole, one of them an asymptote, are they both holes? All right, and so we determine that as you look, do they have matching factors? So x minus 1, is there a match up top? Nope. X plus 3, is there a match up top? Nope. So neither of these have matches. So again, these are both going to be vertical asymptotes. So when we make the graph, this one would actually have 2 vertical asymptotes, one at 1 and one at negative 3. Okay, so our last example, again, 2 discontinuities. If we set the denominator to 0, then there's 2 numbers, x of 2 would make a problem, and x of minus 3. Right, set them to 0. Both of those would create divide by 0 situations. Okay, what's different on this one is the x minus 2 actually has a match. So this x minus 2 factor matches with a factor in the top, so we can cancel it out. And then that means this first one would be a hole. So the x equals 2 would make a hole. Okay, and then the other one, it doesn't match out, right? So the x minus 3, that one doesn't have a match, so that would again be a vertical asymptote. Okay, that is it for the review, right? So this just reviews one of the steps, right? So to find the vertical asymptotes or holes, you look at when is the denominator 0 and then see if it cancels out. Next videos, we'll start to go over the new information.